Hello mathematicians, we're now going to have a look at sequences and how we specify them. A sequence is simply a pattern of terms which follow some rule. And the sequence can be specified in a couple of ways. So one way is to indicate the general term of the sequence. Another way is to give a recursive relationship, one which links a term to the previous one. So we specify the first term and we link a term to the one that came before it. So suppose, for example, we wanted to describe the sequence of all odd numbers. Now, all odd numbers could be written like this: 1, 3, 5, 7, and when we get tired of writing numbers, we put these 3 dots, and it just indicates that this pattern goes on and on. So I could say that I could get all the odd numbers from a formula where the formula is 2n plus 1, where n takes the value of all these integers. So when n equals 0, for example, twice 0 plus 1 gives me 1. When n equals 1, I've got twice 1 plus 1, which gives me 3, and so on. Or I could specify a recursive relationship where I spell out what the first odd number is, and that's 1, and then what the connection is between pairs of successive odd numbers. So the second odd number is the first odd number plus 2. The third odd number is the second odd number plus 2. And we of course get these same numbers, 1, 3, 5 and 7. Now there are lots of different sequences, but in this course we focus on 2 types of sequence: an arithmetic sequence and a geometric sequence. So that's the beginning of our organisation of the content for this topic. So let's begin by considering arithmetic sequences. So an arithmetic sequence is simply a sequence which has a common difference between successive terms. So our recursive relationship is this one, that a particular term minus the one before is equal to a common value. So this is a way of testing whether we have an AP or not. When I say AP, I know it's AP there and we're talking arithmetic sequence, but AP is actually short for arithmetic progression. For all intents and purposes, we don't care. So if we have a series beginning with a first term, which is usually denoted A, and a common difference, which is denoted D, then this will be our pattern. So our first term is A, our second term will have D, the common difference, added to it. So if you like, just checking this relationship here, the second term, Tn plus 1, minus the first term equals D. A plus D minus A equals D. So it's a very technical way of describing something which is common sense. Our third term then will be A plus 2D. Our fourth term will be A plus 3D. And you're probably picking up the pattern now, that what we could say is that somewhere out to the further down the sequence, the nth term will be A plus n minus 1D. And in fact, this is the general term of an AP. So if we wanted, for example, the 20th term of a particular AP, that would be A plus 19 times the common difference. The 100th term would be A plus 99 times the common difference. Our terms are always numbered positively. We can't have a negative numbered term. We can have a negative term, but not a negative numbered term. So they'll always be from 1 upwards. Now, the recursive relationship between these two is that you can get a particular term by looking at the one before and adding D, which is exactly what this said up here. So in a sense, the definition of an AP gives us the recursive relationship. So let's have a look at some examples to do with our APs. So for our first example, find the 20th term of an AP with A equals 20 and D equals minus 3. So we just saw a moment ago what the general equation for an AP is. So to get the 20th term, we want A plus n minus 1 times D, which will simply be 20 plus literally 19, n minus 1 times negative 3. So our 20th term is negative 37. Now for the second question, show that this is an AP. Well, we saw what it is that makes an AP, and that is where the difference between successive terms is a constant. So we could say that 200 minus 193 is 7, and 193 minus 186 is 7. Therefore, we have a common difference, and that's our definition of an AP. Find a formula for the nth term. Well, this is again basically taking this Tn equals a plus n minus 1d and turning it into a formula for the nth term. So for the nth term, we actually know that a is going to be the first term, so that's 200 here. It's fine for it to be a bigger one, plus n minus 1 times our common difference, and our common difference is a difference of minus 7 because we're going down by 7. So now we simply expand that out. So 200 minus 7n plus 7 will be 207 minus 7n. So that's our formula for the nth term. Now for our next question, we just need to understand what they're actually asking. So to determine the first negative term, well, we can see that the 20th term is minus 37. We can see that any term is 207 minus 7 times n. What we really are after is to find the value of n such that the term we're looking at, which is this, is less than 0. So we go ahead and solve this equation. So when we solve this inequality, we get 29 4/7 is less than n. So the first negative term is going to happen when n equals 30. Now for our next example, the third term of an AP is this, and the 12th term is this. Find the 41st term. Now you should be well and truly in command of the fact that if we're given two pieces of information, it's going to involve simultaneous equations. So if the third term of an AP is 16, we know that the third term is a, whatever that is, so we don't know that, plus n minus 1d, and that equals 16. And the 12th term is a plus 11d, which equals 79. And lo and behold, we have two equations to solve simultaneously. So we set about solving those simultaneously. We should be very comfortable with this, and we can get d equals 7 and a equals 2. And once we have that, we come back to our formula. So to find the 41st term, it will be a plus n minus 1d again, which in this case is 2 plus 40 times our common difference of 7. So that's going to be 282 as the 41st term. So we'll have a go at 6D, the even numbered questions. But before you attack those, what are the things that you really need to get your head around for this topic? So clearly the concept of an AP, there are some formulae or expressions, but which are the key ones, which are the ones, the concepts and the equations, which will be repeated over and over again, twisted and turned for all the questions you attack?